Welcome. Today we will see another 4 rules, that is rule number 5, rule number 6, rule number 7 and rule number 8. Up till now we have seen introduction to block diagram, how to obtain closed loop transfer function, that is CS upon RS, and we have seen 4 rules of the block diagram reduction, that is associative law, then blocks are in series, blocks are in parallel, and shifting the summing point behind the block or before the block. Now rule number 5, shifting a summing point beyond the block or after the block. Therefore consider this block diagram. This signal R is there, input signal, it is given to this summing point, another signal Y is there, therefore output from the summing point is R plus Y. That signal is given to this block G, therefore output from the block G, C is equal to R plus Y into G, that is C is equal to RG plus YG. Therefore output is C is equal to RG plus YG, equation 1. Now we have to shift this summing point after the block by keeping output same. Therefore now we have shifted this. In this diagram we have shifted this summing point beyond the block, after the block G. Therefore here R signal is there, it is given to this block G. Therefore R into G, this signal is given to this feedback summing point. Then at the summing point signal we have considered it as X signal, we will find out value of X. Therefore from the summing point output signal C is equal to RG plus X. Here after shifting the summing point after the block, the output is C is equal to RG plus X, that is equation 2. Now comparing equations 1 and 2, we have X is equal to YG. Therefore what we have to do, we have to add a block having its value G or same as that of the block in the signal Y. Therefore this signal R is there, it is given to this block G. When therefore this output from the block G is equal to RG, it is given to this summing point. Again at the summing point another signal is there, that is signal from block G. Again this Y is there, therefore Y into G, therefore value of this signal is YG. Therefore controlled output C is equal to RG plus YG, that is R plus Y into G. That therefore by adding the block having the same value, we have kept the output same. That is, signal Y must be multiplied by a transfer function of the block beyond which summing point is to be shifted, as shown in adjacent diagram. That is, see that we have added here same block having the value of the same block in the signal Y. Therefore this RG plus YG, C is equal to RG plus YG. Thus while shifting a summing point after block, add a block which has same transfer function as that of block, after which summing point is to be shifted in series all the signals at that summing point. This is the rule number 5. Now rule number 6, shifting a takeoff point behind the block. Consider the combination shown in figure below. Now this signal R is there, it is given to this block G, therefore output C is equal to RG. Again this signal is taken off, therefore value of Y is equal to RG. Therefore to shift the takeoff point behind the block, value of taking off point must remain same. What is the value of takeoff point? Y is equal to RG. Therefore for the above case, the output C is equal to RG and value of the takeoff point Y is equal to RG, that is equation 1. Now we have shifted this takeoff point behind the block. behind the block. Therefore, if we are going to shift, the value of that takeoff point must remain same. Now we will shift here. We will see what is the value of y. This is signal r is there, it is given to this block G. Now same signal is taken, that is y, takeoff point is there. Therefore here value of y is equal to r and value of c is equal to rg. That is, after shifting takeoff point behind the block, that is before the block, is shown in adjacent figure. Here y is equal to r, but it must be equal to rg. So a block with transfer function g must be introduced in series with the signal of taking off after the block. Therefore we have to add a signal here, or we have to add a block having its value is equal to g. Therefore we have added here. Therefore signal r is there, therefore this signal is taken off, its value is r. So you have, again this r is multiplied by g, therefore value of y is equal to rg and value of c is equal to rg. Thus, while shifting a takeoff point behind the block, add a block having transfer function same as that of the block behind which taking off point is to be shifted in series with all the signals taking off from that takeoff point. Now rule number 7, shifting a takeoff point beyond the block. Now this diagram is there, this signal r is there, it is given to this block G, takeoff point is there, its value y is equal to r. Therefore from the block G, output c is equal to rg. Therefore consider the combination as shown in adjacent figure. To shift a takeoff point beyond the block, now we have to shift this takeoff point beyond this block. The value of y must remain same, but the signal coming out of the block, that is c is equal to rg. C is equal to rg. Therefore how we will see how the value of y must remain same and how the value of output must remain same. Now see that to keep value of y constant, it must be multiplied by 1 upon g, and the combination would be as follows. Now we have shifted this takeoff point beyond this block here. Therefore rg, therefore signal, this is takeoff point, value of this is equal to rg. Therefore what we have to do, we have to add a block having the transfer function reciprocal of that block. Therefore reciprocal of that block is equal to 1 upon g. Therefore rg into 1 upon g, therefore g and g will get cancelled and y is equal to r. That is value of this takeoff point remains same and value of this c also remains same. Therefore while shifting a takeoff point beyond the block, add a block in series with all the signals which are taking off from that point, having transfer function as reciprocal of transfer function of the block beyond which takeoff point is to be shifted. Therefore this is the rule number 7. Now next, that is last rule, that is rule number 8. Rule number 8, removing minor feedback loop. This includes the removal of internal simple forms of the loop by using standard results. After eliminating such a minor loop, if summing point carries only one signal input and one signal output, it should be removed from the block to avoid further confusion. Therefore, this type of diagram is known as feedback loop diagram or minor feedback loop, in which this RS is the input signal, it is given to the summing point. From the summing point, another same signal is given to this block G. Again from the block G, this controlled output or CS is there. Again this signal is taken off or feedback signal, it is given to this feedback block HS. Again this same signal is feedback or given or provided to this summing point, its value is plus minus. Therefore If such type of diagram is there, therefore we can reduce this diagram like this. RS into the block GS divided by 1 plus GHHS, 1 plus or minus GSHS, and this is CS. Therefore RS into GS divided by 1 plus minus GHHS is equal to CS. Therefore if such type of loop is there, we have to reduce this loop by a block having its value GS divided by 1 plus minus GSHS. This is the rule number 8. Thank you very much. Now all of you study all these rules, and based on these rules we will solve now problems on the block diagram reduction in the next lecture. Thank you very much.